I'm Javier Fernandez. I work for Igalia as an engineer of the web platform team. And I'm going to talk about a new feature that we have implemented in Chrome to allow predefined custom handlers for IPFS. So first of all, I would like to give a quick introduction about the collaboration we have been doing with Protocol Labs this year. We had the long-term goal of making available for browsers to have native support of IPFS protocol. But in the meantime, we would like to improve the situation so that the IPFS network is flexible using the gateways. That's the short-term goal and what we have been working on these years. We really believe that all the work we are doing benefits not only the IPFS community, but the web platform community as a whole. We started the collaboration in 2020, and the first years we have provided to the web platform important improvements in different browsers about in the area of the secure context, also local host and loopback networking, and of course web extensions. We improved the situation. The IPFS companion extension is really useful for the community, and we have fixed several bugs there. Lately, we have applied an important refactoring in the Chrome codebase that came with a new component for the protocol handler logic. And of course, on top of this refactoring, we have implemented a way of adding predefined handlers for different schemes. As many of you know already, the protocol handler allows to register a handler for a scheme that is not natively supported by the browser, for instance, IPFS. And the idea is that the URL requests are redirected to the handler URL. The HTML API is pretty simple with just the scheme and the handler, but it requires some restrictions. Either the scheme is prefixed with the Web Plus, or be in the HTML safe list. Also, the handlers must be of the same origin than the registration page, and also, that's important limitation, requires confirmation from the end users to authorize the registration. So let's talk about now this new component that is part now of the Chromium codebase. Why a new component? Well, the main issue that we wanted to solve is to allow Chrome embedders to share all the custom handlers logic that was before part of the Chrome specific bits. Other advantage is to avoid code duplication of the security and privacy logic that is run by both the render and browser processes, and also improve the web platform test coverage, including test automation. That's still a goal, but we are close. As a secondary goal as well, we want to clean up and unify the different notions of the secure context that are still in the Chrome implementation, and also in WebKit-based browsers like Safari. So as I said, the protocol handler was part of the Chrome-specific codebase. So forking was the only way to use it. You have to fork Chromium to use these features. And patching is the only way to upgrading or improving the custom handler logic. So the new component makes the protocol handler independent from the logic that is specific to Chrome. There is still two classes that are important that remain in Chrome, as the Chrome delegate that provides the integration with the operating system. And embedders can provide their own delegate depending on the operating system they want to run. And then the factory, which is what creates the appropriate instance of the delegate, and it also provides some Chrome-specific logic like incognito mode and this kind of profile management. Yeah, as I said before, one of the goals of the refactoring was to reduce the code duplication of the privacy and security checks that the registered protocol handler has. There are different implementations of these checks that are run by both the render and browser processes, and they have some difference in how they were implemented. We have moved all this logic to Blink, which, as you can see, is the main part of the web engine. So now both the web contents IMPL, that is run by the browser process, and the navigation content utils, that is what is run by the render process, now both use the same class where these privacy and security checks are implemented. So let's talk about now, this was the refactoring, and on top of this, we implemented this new feature, which is predefined handlers. The idea is that allow the browser to register the handlers at compile time. So this is not new, because Chrome OS already was using these mechanisms to register handlers for mail.to and webcall schemes, which were redirected to mailgoogle.com and Google Calendar. So we get that idea. Yeah, first of all, a bit of a concept that is very important, which is the scheme registry, which is where all the schemes that the browser knows are declared. There are different lists of schemes, and the browser can implement different behaviors for each list. You can have a secure schemes list, and knowing that this is a secure scheme, you can implement different behavior. So the idea is to use that, and the API that Chrome already provides for embedders to add new schemes, to use the scheme registry and create a new list that contains schemes that have predefined handlers. That way, we provide embedders an easy way to extend the number of schemes that are valid for these predefined handlers, and provide the custom handlers at compile time. I have a simple demo. The only two lines that you have to add just to make Chrome use the HTTP gateways for any IPFS URL that is in the top level navigation, or even link to clicks. Yeah, since the browser doesn't understand the scheme, there is no extension there. There is no protocol handler, so the browser just open Google search and search for the term. So now I'm going to apply a simple patch, and we compile Chrome again with this small change. Yeah, and now it directly understand the scheme and use the custom handler that redirects the URL to the gateway. So yeah, this is not the ideal situation because you still have to patch Chrome. So there are several things that could improve this. We could perhaps land this behind experimental flag, a runtime flag that the end user can activate on demand. Or there are different ways that we can do this. But yeah, I think this is a good start, and then we need to discuss this with the Chromium community to see if this is useful or not for the whole. And this is also available for any other scheme, not just IPFS. So why predefine handlers? The main reason is that introduce a custom behavior for specific schemes without user interaction. We don't require users to install anything. We don't require users to authorize. Of course, there should be, if this is a feature that is shipped by default, we should warn the user that this is going to happen. So for instance, the first time the user clicks an IPFS link, it's going to be warned about a handler is going to be to redirect the request to a HTTP gateway, so the user is aware of this. But also another advantage is that we can bypass some of the restrictions imposed by the HTML API. Since we do this at compile time, and it's an embedder browser that we know the use we want to give that, and the user, when they install, the browser knows the capabilities, we can assume that the handler is safe, and we don't need to check for the same origin registrations restriction. Also, we can bypass the handler URL syntax that requires the percent code there, so we can add there whatever we want for the handler. That could allow to implement smarter handlers. But the custom handler validation still applies. What does this mean? The schemes should be HTTPS or extension schemes. Handlers must be a potential trustworthy URL, and it must be in the safe list. We will talk about that later a bit, that the restriction that the scheme must be in the safe list. Yeah, what's next? I mean, we will continue working on this for the next years. And one of the important areas we will still working on is the unification of the secure context concept. This is a fundamental concept for the custom handlers logic, and there are still inconsistencies in the implementation between the render and browser processes, so we will plan to continue working on that. Testing automation, as I said, one of the advantage of the refactoring we made is that now we can run the web platform test with the content shell. The content shell is a minimum browser that is part of the Chromium code base. This content shell is what the Chromium infrastructure bots use for the continuous integration. So having support for protocol handlers there give us some good measure about regressions, but the tests that are available in the web platform test infrastructure are manual. Why? Because, as I said, the registered protocol handler requires user interaction, and the browser ignores any request that is not activated with a transient user activation. That means a click, an active event. There is an API in the WPT infrastructure to bypass this, but we still need the user authorization. We need some kind of thing to automate the permission, to grant the permissions. For that, we are exploring a new WebDriver command. WebDriver is a specification for testing automation, and we are proposing to the WPT community a new WebDriver command to just put the browser in some mode that can auto-accept or auto-reject any request. Yes, I say this would allow us to change all the tests that are now manually to automatic tests that are run not only by the Chromium infrastructure, but the web platform test infrastructure, which is cross-browser. So we can detect regressions in Firefox, in Chrome-based browsers like Edge or Opera, but also Safari, if eventually they implement the API. But yeah, I think that's important because it ensures that we apply change in a correct way. Yeah, that's as an example of how challenging is this process of standardization. We need to provide a PR for the HTML spec because the WebDriver command is used by this spec, and we need to provide new tests and a request for commands because we changed the infrastructure of the WPT infrastructure. Then there is the Chrome intent, and we need to also ask the other browsers for opinion, because if we want this to be a standard, it must be approved by at least 3 major browsers. So this is the politics of making this a standard, which I think it makes sense. I mean, the changes are slow but robust. And as I said, one of the goals, yeah, long term, we are not in a hurry, but the HTML spec defines a safe list of schemes that are considered safe, and as you see, IPFS is not part of this list. Unfortunately, Chrome accepted a change to consider IPFS safe, so at least in Chrome we don't have to worry about that. But in other browsers, for instance Firefox, you are forced to use the prefix. One of the reasons why they still are not sure about that is that, yeah, the operating system relies on URLs for applications as well, and they don't want to hijack that functionality for the web. And also, there is not a clear definition of when a scheme is safe. But yeah, we managed to get a specific list of milestones, and we will get there eventually. And this is another idea that we are exploring. The IPFS protocol handler allows us to understand or access the IPFS network, but only in the top-level navigation when you click links. But what happened with the other resources that a web has? For instance, what about the style sheets? What about scripts? What about the other things that a site can have? Ideally, all those resources should be retrieved using IPFS. So register protocol handler, so far, the HTML is not enough. Doesn't work like that. So the sub-resource integrity is a specification that wants more to ensure that what you ask is the specific content. So the idea is to use that pattern of what instead of where to retrieve or indicate that we want to retrieve the content using IPFS. So the integrity attribute would be not only for integrity, but also for access. Yeah, and finally, the last thing we were working on, not related to protocol handler, but also a benefit for the web platform, is the WebKit API improvements to add safe curves. We are working on adding the Edwards 25.5.19 and the key agreement algorithm. We are ongoing. The implementation has started and is ongoing in Chrome, and we have got some positive signals from Safari and Firefox. So yeah, we are confident that this will be one of the achievements of the next year. And yeah, thank you. Sorry for the long talk.